Welcome back, everyone. We're diving into a real head-scratcher today. A cosmic puzzle that's been bugging astronomers for over a decade now. The Galactic Center Excess, or GCE if you want to sound like you're in the know.
Yeah.
Basically, picture this. There's this mysterious glow of gamma rays coming from the very heart of our galaxy. The Fermi Gamma Ray Space Telescope first picked it up back in 2009, and it's been a source of debate ever since.
Yeah.
We're talking serious energy here, way beyond what we'd normally expect.
Yeah, it really throws a wrench into our understanding of what's going on at the Galactic Center. All sorts of theories have been thrown around trying to make sense of it. The two main contenders both involve some pretty mind-blowing physics, annihilating dark matter or a whole bunch of millisecond pulsars we haven't spotted yet.
Okay, let's break that down a bit for our listeners. Start with dark matter. It's invisible, makes up a huge chunk of the universe, and we can only really tell it's there because of its gravity. So how could this invisible stuff be behind all those extra gamma rays?
Well, the idea is that dark matter particles could be their own antiparticles, right? So if they bump into each other, they annihilate, poof. And that releases energy, sometimes in the form of gamma rays. Now, the Galactic Center is super dense, packed with stuff. So if there's a lot of dark matter hanging out there, those collisions could be happening often enough to create the GCE.
So basically, dark matter could be having these invisible fireworks shows at the center of the galaxy, and we're seeing the afterglow. That's wild. But haven't there been problems with this explanation?
The biggest issue is we haven't seen clear signs of dark matter annihilation anywhere else. Not yet, at least. And even if it is happening at the Galactic Center, the strength of the signal depends on what kind of dark matter we're dealing with.
So, is it heavy dark matter, light dark matter? Does it like to bump into itself a lot, that sort of thing?
Exactly. There are tons of models out there for dark matter particles, each with its own quirks, but none of them have really nailed it, haven't quite fit all the data.
So dark matter annihilation is a contender, but maybe not a champion just yet? What about those millisecond pulsars you mentioned? I've heard they're pretty intense.
Oh, they're powerhouses, like spinning neutron stars blasting out radiation. We know they emit gamma rays. So imagine a whole hidden city of these things in the Galactic Center. Their combined gamma rays could potentially create the GCE.
A whole hidden city of pulsars. Whoa, that's a mind-blowing picture. But I'm guessing there are some wrinkles with this explanation too.
Yeah, a few. First off, we haven't actually found enough pulsars in the Galactic Center to account for the GCE. And the ones we have found are kind of weird. The way their brightness is spread out, their luminosity function, it doesn't match up with what we'd need to explain the GCE.
So to put it simply, if pulsars are the culprits, they'd have to be different from the ones we've seen elsewhere, maybe fainter and way more plentiful.
Yeah, precisely. And that raises the question, why would Galactic Center pulsars be so unique? It's possible, but we'd need a solid astrophysical reason.
Okay, so we've got two big suspects, both with their own strengths and weaknesses. It sounds like this cosmic mystery is far from solved.
Exactly, and that's what makes it so fascinating. Stay tuned, because we're going to dig deeper into this puzzle and explore some of the latest research. And who knows, maybe we'll find some clues that point us in the right direction.
I'm definitely intrigued. I can't wait to hear what else you've uncovered. For our listeners out there, hang tight. We'll be back in just a bit to explore more of this cosmic enigma. So we've got this cosmic whodunit on our hands. And for a while, it seemed like the shape of the GCE itself might give us a big clue. There was this talk about the excess being clumpy, like it wasn't a smooth glow, but more like a bunch of bright spots all clustered together.
Yeah, that was a big point in favor of the pulsar explanation for a while, right? A bunch of pulsars scattered around would naturally create a signal that's kind of patchy and uneven, whereas dark matter annihilation, you'd expect a smoother, more diffuse glow because it's spread out.
But you mentioned earlier there's been some new research on the shape of the GCE. What's the latest on that?
Well, this is where things get even more interesting. Several recent studies have actually challenged those earlier claims about the clumpiness. They use some really sophisticated data analysis techniques, much more powerful than what was available before. And guess what? They found the GCE is actually pretty smooth and symmetrical, shaped like a sphere. And that lines up better with the dark matter annihilation picture.
So the shape of the GCE is pointing us more towards dark matter now.
It's not a slam dunk by any means, but it does make the dark matter explanation more compelling. Yeah. Of course, we can't just focus on the shape we have to consider all the evidence together.
Right. It's like trying to solve a puzzle. You can't just look at one piece. You have to see how they all fit together.
Exactly. It's a bit like detective work trying to piece together the clues. And sometimes the hardest part is knowing what we don't know yet. There could be other things going on in the Galactic Center that we haven't even thought of, things that could be contributing to the GCE.
It makes you realize how much we still have to learn about our own galaxy, let alone the rest of the universe. But let's get back to our two main suspects for a second. If we had to place bets right now based on what we know, which one would you lean towards?
Ooh, that's a tough one. I don't want to give the impression that we've got it all figured out. Both dark matter annihilation and pulsars have their challenges. But if I had to pick a side, I'd say the evidence, at least right now, is slightly more in favor of dark matter.
So this invisible stuff might be the source of those gamma rays coming from the center of our galaxy. That's kind of a mind-blowing thought, isn't it?
It really is. And it shows you the power of using gamma rays to study the universe. These gamma rays are like messengers carrying information about some of the most extreme environments in the cosmos, places where matter and energy are behaving in ways that we're only just beginning to understand.
It's a reminder that there's so much more out there to discover, so many mysteries waiting to be solved. But for now, the GCE remains an enigma. It really feels like we're at a crossroads with this whole GCE thing. The evidence seems to be tilting towards dark matter, but there are still so many unknowns.
Exactly. And that's what makes this research so exciting, right? We're pushing the boundaries of what we know about physics and the universe itself.
So let's just say for a moment that dark matter annihilation really is the culprit behind the GCE. What would that mean? How would it change our understanding of dark matter? Would it have implications for other areas of astrophysics or cosmology?
Oh, it would be huge. It would mean that dark matter isn't just this passive, invisible stuff. It's actually interacting with itself, which means it has properties we haven't even begun to fully grasp.
So instead of just influencing the universe through gravity, it could be a much more active player on the cosmic stage.
Exactly. And that opens up a whole new can of worms. What are the specifics of these interactions? What other particles are created? Could these interactions have played a role in how galaxies formed, or even in the very early universe?
It's like finding out your quiet neighbor actually has this whole secret life full of intrigue and mystery.
I love that analogy. And this new understanding of dark matter could have a ripple effect across many areas of astrophysics. For example, it could change how we interpret observations of galaxy clusters, which are also thought to be full of dark matter.
So the GCE, even if it doesn't give us all the answers, could be the key to unlocking a much deeper understanding of dark matter and its role in shaping the universe.
Absolutely. And this is where ongoing and future research comes in. New telescopes like the Cherenkov Telescope Array will give us much more detailed observations of gamma rays, allowing us to study the GCE with much greater precision.
And more data usually leads to more clues, right? Maybe we'll find some subtle features in the GCE that point more definitively toward one explanation or the other.
That's what we're hoping for. And we also have much more sophisticated data analysis techniques being developed all the time. These techniques allow us to really sift through the data and extract subtle signals that might have been missed before.
It feels like we're on the verge of some major breakthroughs in our understanding of the universe. And the GCE is right at the center of it all.
It's an incredible time to be an astrophysicist. There's so much we don't know, but that's what makes it so exciting. Every new discovery just leads to more questions, pushing us deeper into the mysteries of the cosmos.
Well said. So to all our listeners who joined us on this deep dive into the Galactic Center Excess, remember that this is still an open question. But it's a question that's driving some of the most cutting-edge research in astrophysics and cosmology today.
And who knows, maybe one of our listeners out there will be inspired to join the quest for answers and make the next big discovery.
That would be amazing. Keep exploring, stay curious, and never stop questioning the universe. Until next time, keep looking up.